Very good evening to everybody. Can you listen to me? Please raise your hand. Yes, this is EC circuit analysis or network theory, and I basically teach for full-time PM and IES students of GATE, ES Batch learning career. I don't take 4 offline request study, sir. House session, request me to solve it. Yes, everybody listen now. This subject is called as network analysis or network theory. We call okay, network analysis or network theory for EC students. Okay, it is called network analysis or network theory for EC students. Okay, then it is also called, yes, it is also called as electrical circuit analysis. Let me write this. It is also called electrical circuit analysis. Okay, circuit analysis for EEE. And the circuit is also called basics of circuits. Okay, basics of electrical circuit analysis for EEE and basics of circuits for instrumentation. Now, my first question to you is how to get full marks in my subject in network theory or network analysis. I will write different names, but 90 to 95% of the subject and syllabus is common. Everybody please understand, 90 to 95% syllabus is common for all the branches, except like topology is there for ECE, 3-phase is there special for EEE. That's it. That is the only difference. And instrumentation syllabus, you are close to EEE syllabus. Yes, but understand that in ECE, frequency domain analysis is giving more importance, and EEE time domain analysis is giving more importance, which I will tell you, sir. Don't worry. All these basics I will tell you, all these definitions I will tell you. That is my duty. Now, everybody. So this is network analysis for ECE or electrical circuit analysis for EEE. Okay, full marks in my book, which I will do it. Plus, volume 2 is revision and homework. This is revision and homework. Okay, revision and homework. So everybody please listen now. Step 1, first notes. Please write notes. I know in online you can listen to me like as if a movie is going on, but I still recommend you please write notes. Take some papers, write along with me. Problems especially, not this general content. Okay, general content, general instructions I don't want you to write, but especially I want you to write the problems. Any question I ask, try to solve along with me. That will be very important. So what I'm recommending everyone is, please maintain notes. We will also send you the soft copies every day. All this content, what I'm writing in PDF format, we will send it, no doubt. But sir, live, you should be alive and you should be interacting with me. So what I suggest is, please write notes along with me. So take a pad and put a lot of A4 plain papers and do. Because sir, your mind and body should be together. If you just listen, watching, this cell phones and a tab or computer, you will get distracted, sir. So please understand that you maintain a pad, lot of white papers, take some pen or pencil and keep writing with me whatever problem, the real. So step 1, everyone should, I also say, of more than 350 batches. Understand this. All the senior teachers here in every subject which are coming for your batch, we have experience of T to be in our so engineering. I'm challenging you. In ACE, we put a lot of. See, first of all, exam means only these 4 points. 80 and you want PSU job. It's different level altogether. And my notes cover these 2 books. Have a reference. You can have this. Now, example, ideal DC look like this. Ideal DC look like this. Now, tell me, sir, does this ideal DC voltage exist or not? Does this ideal DC voltage exist or not? Okay, you write in question and answer, anyone. Does this ideal DC voltage exist or not? Anyone write it? Anyone write it? Does this ideal DC voltage exist or not? Now I'm getting some answers. Some students say no. Okay, some students say no. But listen, sir, I will tell you. Okay, that's enough. Now listen, sir. See, ideal DC is very difficult to generate, but it exists at signal level for small power levels using our function generators and regulator ICs. Sir, your EDC analog lab is there, na, sir? In EDC analog lab, 5 volt DC in horizontal line in CRO, you see or not? Yes, that is the best example. And also a newly purchased battery. So if someone asks, does ideal DC voltage exist? You should say, ideal DC voltage may exist only at certain small primitive power level. When a new battery is purchased for first few hours, suppose you purchase a new battery, 1.5 volt cell is there, na, sir? For first few hours before it discharges, it almost maintains constant voltage. And it keeps discharging. But after some time, na, sir, it discharges and its voltage characteristics go down. Similarly, regulators. See, 78XX ICs, 78XX. Anyone remember these ICs in your analog lab? 7805, 7812. You remember, na, sir? Voltage regulators, sir. These integrated circuits are specially decided or designed voltage regulators. Like 7805. 7805 voltage regulator is a 5 volts IC. Similarly, 7812. If I write 7812, it is a voltage regulator with 12 volts. Like that, in our analog lab, in breadboard, we connect those voltages. Do you remember, sir? 5 volts, 12 volts. Yes, sir. This is that IC, sir. So, ideal DC is very difficult to generate, but it may exist only in certain areas at small signal level. Yes, it exists in only certain areas at small signal level, like a newly purchased cell. and a voltage regulator in analog lab up to few milliwatts or watts only. Okay, na? Now when ideal DC is given, otherwise rest all are practical, sir. Now normal rectifiers with filters. Okay, all these are practical. DC generators. Okay, solar cell also is good, but based on the intensity of light, the voltage keeps varying, the current keeps varying. So that is also not perfectly ideal. In the afternoon, full bright sun, you will get very good regulated voltage, but later in the evenings you may not get. So I cannot guarantee that is also ideal. But in my subject, the first part, which consists of 3 chapters, is ideal DC circuit analysis. Ideal DC signal look like this. The green line is there, na? Like in your EDC analog lab in CRO, horizontal line will come, na? That is the ideal DC. Now for ideal DC, dV by dt resistance and pure capacitor. So even if I take, na, sir, in steady state, inductor short I have to take, capacitor open circuit I have to take, because pure inductor is made out of wire with zero resistance, and pure capacitor dielectric resistance is infinity. Understood, na, sir? So that way, yes, the first 3 chapters are ideal DC steady state. Okay, na? Then, sir, then there is an extra chapter after the first 3 chapter. Chapter 4 is extra, which I will tell you. Chapter 4 is extra. Then there is an extra. Then, sir, then there is an extra chapter after the first 3 chapter. Chapter 4 is extra, which I will tell you. Chapter 4 is extra, I will write. But this is not part 2. This is only extra chapter. Okay, which will give basics of time variance. Basics of time variance. Time variance. Especially such waveforms are given to inductor and capacitor. Now listen carefully. What happened in the first part? First part is first 3 chapters. In first 3 chapters, I will give ideal DC only. That includes DC basics, resistor reduction techniques, methods of analysis. Okay, then we come to network theorems. All this will come into first 3 chapters, sir. Okay, that will come into first 3 chapters. But ideal DC, inductor short, capacitor open, only resistor we will study. Now, 4th chapter is the secret chapter when we introduce inductor and capacitor. 4th chapter is the secret chapter when we introduce inductors and capacitors. That is basics of time variance. Now in this chapter also resistor is working, but we need not specially study because resistor is a homogeneous proportional component. But in this chapter, I will now give different waveforms. Like I will give ramp voltage. Means resistor is still homogeneous and proportional component. Homogeneous, okay, and proportional component. Proportional component. That means what happens in resistor? Yes, in resistor, what happens is genius, okay, N-E-O-U-S, okay. What is the meaning? Resistor is a homogeneous and proportional component. That means you ramp voltage, ramp current will flow. Square voltage, square current will flow. Triangular voltage, triangular current will flow. So resistor is not a problem. But L and C will start working. L and C behave differently. They behave differently for different excitations. That we should study. So chapter 4 is very small but interesting chapters are where we give basics of time variance. Now what is this basics of time variance? Yes, I give different inputs. Based on the different inputs, the behavior of L and C is understood. That is very interesting chapters are very interesting. That we should know because in first 3 chapters in DC, what happened? Inductor is short circuit in steady state, capacitor open circuit in steady state. But yes, when we go here, inductor and capacitor start behaving, and that secrets we should apply part 2. What is part 2? Part 2 is ideal AC. What is ideal AC? Ideal AC is a sinusoid. Sinusoid means it can be either sine wave or cosine wave. So part 2 will be steady state AC circuit analysis. Now this contribute chapter number 5, 6, 7, 8, 9, 10. I will tell you what are those. Okay, 5th chapter will be AC basics, 6th is AC power calculations and phases. Okay, 7th will be locus diagram, resonance, magnetic circuits. All this will come under, yes, these topics. Don't worry, that chapter division is only my internal reference. Don't worry about those things. Because however, while writing each chapter, I will write heading and explain to you. Don't worry. So, but part 2 of my subject, which consists of chapter number 5, 6, 7, 8, 9, 10, is about ideal AC circuit analysis. Now, which is ideal AC? Sinusoid. Ideal AC is sinusoid. So, sinusoid means it can be either sine wave or cosine. Okay, I am writing it here again. It can be either sine wave or cosine. Like 0, pi radians, 2 pi radians, Vm positive maximum, minus Vm negative maximum. So, yes, this function V is like Vm sine omega t, or you can also take Vm cos omega t. Anything is all. But sine 4 not necessary. Then a pure capacitor is called leading element. Yes, in a pure capacitor, if you give sinusoidal voltage, current is also sinusoidal, but current will lead voltage by 90 degrees in phase. So, yes. Now, when I give AC steady state analysis or sinusoidal circuit analysis, resistor is still in phase element. Okay, resistor is still in phase. In phase means yes, current and voltage are in phase. There is no phase shift. But pure inductor is a lagging element and pure capacitor is a leading element. Yes, sir, that is what is exactly happening. Why that happens? What is reactance? What is impedance? All this we will study, sir. But it is very interesting. And this is the dominating part. Okay, this is the dominating part, which includes resonance, magnetic circuits, locus diagrams, power calculations. All this will come in this part. Big part. Yes. Compared to DC, this is a very big part and more mathematics are involved because phasor calculations are always tougher than DC. In DC, what happens, sir? All are like simple numbers. Okay, DC. Once you know such basics of time variance, then understand the change. Transients means change. Anything sudden change. Okay, transients means anything is sudden change. Steady state means steady state. See, DC steady state means already the switch is closed, everything turned on, and everything is safe. Now they are working in steady state. AC steady state means AC voltage is turned on, already transient happened, but they reached a steady state and now they are working normally. But this state is about transient state, sudden change state. Okay, like for example, a network is there, okay, consisting of linear elements like RLC, and you are giving excitation. Okay, you are giving some excitation, and this voltage, yes, this voltage could be DC or AC. Okay, but here I'm showing a switch to indicate the sudden change. I'm showing what? Yes, I'm showing switch to indicate sudden change. I'm showing switch to indicate sudden change. So please understand, sir. Everybody please understand. This is called transient circuit analysis. Okay, transient circuit analysis. Like suddenly closing the switch will turn on the circuit. Now when sudden transient is given, yes, in transient state, sudden change at t equal to 0 plus, this is very different. Resistor is normal. Resistor is still homogeneous and proportional. Homogeneous, okay, and proportional. Okay, but inductor, ulta, open circuit, capacitor, short circuit, ulta. Very interesting, sir. But in this chapter, sudden change, ulta. It looks where we get ideal DC. Ideal DC is not easy, but we get when a new purchased battery for few hours. Okay, not current, only resistors will work, and that is why homogeneous proportional Ohm's law. Square voltage, square current, triangular voltage, triangular current, exponential voltage, exponential current. In which element resistance? That is why resistor is independent to frequency, we say. But inductor, capacitor, they behave differently, sir. How they behave that we should study. Ramp voltage, what current will come, pulse voltage, what current, all these secrets we'll study. But part 2 will be sinusoidal AC steady state analysis. Okay, there resistor is still normal, homogeneous proportional in phase, inductor is lagging, capacitor is leading. Okay, then the transients, the switching state. Okay, this is very, very interesting, sir. Very interesting. By the time we come to this chapter, everything is so interesting that you'll enjoy it. Okay, then sir, 9 to 12 months is your average out of 100. Minimum 9, maximum 12. Okay, one time it came even 6, sir. Sometimes bad luck. I remember in 2018, your network paper hardly 6 marks came. Okay, sometimes it may go down. That all competitive exam, sir. Okay, that depends. I remember in one paper in APS, PDCL, something in 1 year, only one bit came. Only one bit came. So we cannot guarantee anything. In competitive exams, he will do anything, sir, to eliminate people. But otherwise, average. Yes, in GATE is 9 to 12 marks. Okay, in GATE, 9 to 12 marks average. In GATE. But when it comes to IES, I talk in terms of bits. Okay, you know, IES technical 150 bits will be there. Okay, 150 bit. So I will say somewhere around 15 to 17 bits are objective out of 150 in ESC prelims. ESC. This is very interesting. Okay. So what is interconvertibility? Yes. And 2. This is very interesting. Okay. Electric. And 2. Transportation. That are the two ultimate reasons. Okay. Electrical energy is one of the most dominating, and everything is your problem. Can we get this electrical energy from heat or not? Electrical energy from any? So the biomass, etc., etc. So the beauty of my energy is that too for longer distances, long through transmission. It is 1000 watts consumed for 1 hour. Now such a huge quantity with a lot of subsidies, etc. Yes, in India, yes, more than 70%, greater than 70% of population. Okay, greater than 70% of population, including farmers, etc. We are hardly getting for ₹3 per unit. Now tell me, sir, which energy is so cheap as electrical? No one can do, sir. See, the beauty is economical also, sir. 1 unit of electrical energy is 1 kilowatt hour, sir. What is 1 kilowatt hour? 1000 watts consumed for 1 hour is called 1 kilowatt hour. 1000 watts consumed for 1 hour is called 1 kilowatt hour, and that huge energy also. More than 70% of population in India in suburban, rural, farmers. Average cost is only 3. In some states, farmers free power, sir. Yes, in most of the states, farmers are getting free power. That is very essential for India. Okay, otherwise farmers don't do that. We cannot even live. So that is very free for farmers. But average, if you take ₹3 per unit, and it is 1000 watt hours. No other energy is as cheap as electrical. Okay, now that is of 2 reasons. So if someone say, sir, why you took EC or instrumentation? That is the answer, sir. This energy, what we are dealing in communication systems or power level, transducer, signal processing is great energy, sir. This is a great energy. Why is this a great energy? Because of interconvertibility and transportation. I told interconvertibility is a process where we can convert different forms of energy into one common platform and you can transport it back or convert it back. And transportation, yes, we can transport this energy anywhere in the world. Yes, anywhere in the world. Okay, both in bulk quantities and small packets and longer distances and most economical. That is the reason this energy is very, very special. Okay, now, sure, now serious answer. Everybody should listen now. Okay, this is an introduction class, sir. Don't get bored, please. This is very important introduction, sir. Everything we will teach, sir. From 0 level I will teach. And last day you tell me you will enjoy this subject. And last day you tell me how much happy are you in this subject. But that will take a lot of time, sir. You should have patience. Yes, you should have patience. If you don't have patience, I cannot do any magic. I'm telling you. So last day you see how much you will enjoy. So what I told about these two energies, yes, that is what I told. Interconvertibility and transportation. So now, yes, and we are learning about this great energy. As EC students or instrumentation students, we are learning this great energy called electrical energy. Yes or no? But we learn this energy both at signal level and power level. Now see this energy, yes, this EEE students, okay? EEE students, sir, they learn this energy at power level. What is power level? Power level is high level. They talk in kilovolts, kiloamperes. Power is in megawatts to gigawatts, Let me power in megawatts to gigawatts. But their frequency of power system, in power system is 50 Hz, low level only. So sir, this energy, electrical people, they study at power level, sir. Power level is high level. High voltage, high current, high power, but frequency in power system is 50 Hz constant. So all their transmission line towers, big power poles, etc. They are working with high voltage, high current. That is known to us. But their frequency is how much? 50 hertz. But the same energy, yes, this ECE students, but this same energy, this ECE and instrumentation study at signal level. We all study at signal level, sir. What is signal level? Low level. Okay, millivolts to few volts. Okay, then milli or microamperes. See, microampere to hardly few milliamperes. Then power, milliwatts to few watts. But our frequency of communication and signal processing, is in kilohertz, megahertz, and even gigahertz. Okay, kilohertz, megahertz, or even gigahertz. So please understand this, sir. Everybody should know this. So we are coming to important things. See, first of all, electrical energy is great energy. I gave the two simple reasons. There are so many reasons, but I gave the real conclusion. Interconvertibility and transportation. Sir, you tell me instrumentation students, sir, you are there in the class. Transducers is all about interconvertibility, sir. Strain gauge. Okay, so many things you study, sir. It's all converting into electrical signals, sir. That is the beauty. So interconvertibility and also transportation. Communication people, are you not transporting everything electrical signals, sir? Your electromagnetic waves, transmission line waves, is all electrical signals, sir. So that is the beauty. So we are learning this great energy now at both levels, power level, signal level. Who is learning power level? To be students. High voltage, high current, high power, and frequency in 50 hertz. But EC students learn this and instrument learn signal level. Signal level is low voltage, low current, low power. But frequency in communication and signal processing is very high. Kilohertz, megahertz, gigahertz, audio frequency, radio frequency, video frequency, etc. Now, everybody should see that both these lines travel parallelly. When you go in a train, everybody listen. When you go in a train, yes or no? Everybody, when you go in a train, okay, one side you see power lines, big towers, yes or no? One side you see power lines. Yes, one side you see telephone lines. Okay, one side you see power lines, one side you see one student wrote, sir, why are you using word electrical? Because in IIT, electrical engineering is common. In IIT, sir, electrical engineering means ECE instrumentation coming one branch. You see even Hayden, Kimberly, and Alexander, they write electrical term. Not electronic. Electronic is a part of electrical. Even power is a part of electrical. You go to IIT websites, okay, signal level. They're talking signal, etc. Listen carefully. So, because electrical people are talking this energy at power level, for them efficiency, power factor, cost, voltage regulation, safety are important. But for us, listen carefully. But for us, because we are talking at signal level. Listen carefully. For us, yes, precision, accuracy, speed, compact, portability, portable, okay, compact, portable, okay, and automation, and intelligent is our requirement. So now EC and instrumentation, what is our requirement? Because we are talking at signal level, low level, okay, precision, accuracy, speed, compact, portability, automation, intelligence are our parameters. But electrical people, they talk about efficiency, power factor, cost, voltage regulation, their parameters. Example video, very interesting, listen carefully. See, don't underestimate my introduction. Some students are leaving already, some 4 students left. I'm telling you, sir, you will enjoy this subject as I go deep. First day, I cannot do any magic. At least some 6 to 7, 8 hours you get, then you enjoy this. Until then, I cannot do any magic. It's up to you. Okay. Then moreover, this is the first class, sir. First class introduction. I'm starting from scratch, zero level. And you know, this subject is the first BTech subject we study now, sir. Everyone tell me, this is the first BTech subject. Why it is given as a first BTech subject? There is a reason, sir. There is a reason is called lump parameters. I will tell you. So now see here, we are learning this energy both at power level, signal level. Electrical people study power level. EC students and instrumentation signal level. Signal level means low level, low voltage, low current, low power, but frequency is very high. All the electrical products at power level, their performance parameters are efficiency, power factor, cost, etc. But all the electronic and instrumentation products at signal level, our target is precision, accuracy, speed, etc. Example. You all know Bajaj Electronics, sir. You all know Bajaj Electronics. You went anytime. Bajaj Electronics is a consumer electronic shop which will give all the products in a house. Yes or no? Bajaj Electronics is a consumer electronic shop which will give all the products. Yes or no? Suppose in Bajaj Electronics, you buy an air conditioner. Okay, if you buy air conditioner, now tell me, sir, air conditioner is power level or signal level? Everybody tell me. I will see some answers. So air conditioner in Bajaj Electronics. Air conditioner in Bajaj Electronics is power level or signal level? Tell me now. Okay, this air conditioner in Bajaj Electronics, yes, everybody, is what? It is power level. Yes or no? Air conditioner in Bajaj Electronics is power level. Okay, yes, sir. Now, how to buy AC then? Then what you see, everybody tell me. What you see in AC, everybody tell me. In what you see in AC, you see star rating. Yes or no? Whenever you go to Bajaj Electronics, you will say, Bhaiya, what is that star rating? 5-star rated AC, 3-star rated AC, 4. You will tell, sir, 5-star rated AC, copper condenser is there. Its power factor is high. Efficiency is more. Inverter technology. There is inbuilt voltage regulator. More safety. That is what you will tell, sir. So when you buy a 5-star AC, which is power level product in Bajaj Electronics, because 1 ton AC is approximately 1 kilowatt, 2 ton AC, 2 kilowatt approximately. Okay, so yes, 2 ton AC is approximately 1960 watts, sir. Okay, but approximately 2 kilowatt. So what happens in Bajaj Electronics when you buy air conditioner? What you see is star rating. What is the star rating? Efficiency is more, power factor is more, copper condenser, so less voltage regulation. All this we will see. Okay, that's why when you buy air conditioner, which is power level product, which is high voltage, high current, and high power, there you have to see such things only, sir. Efficiency is how much cost it is saving. Okay, suppose you buy 3-star rated AC, 3-star rated AC, aluminum condenser will give aluminum what happens, low power factor. Okay, less efficiency, no inbuilt voltage regulator, all these problems will face. So that is why air conditioner is a power level product. And when you buy air conditioner, yes, you have to see such performance parameters. But sir, now see here. This great energy is because of interconvertibility transportation, and we are learning both at power level as well as electrical level. Okay, and the signal level. Signal level, I told example cell phone. Yes, I'm writing this now. Yes, example air conditioner, like 2 ton means approximately 2 kilowatt. Okay, it is power level product. So their efficiency, power factor is only important. Then cell phone. If you go to cell phone, yes, okay. Luckily with CRO today we are able to understand something. But before CRO, you imagine how the world was there. Before CRO, how the world was there, we don't even know anything. We were not even comfortable what is DC signal and AC signal. So please understand that. Yes, everybody. What is the difficulty in understanding this electrical networks for ECE or instrumentation? To believe the simple reason is in understanding this great energy, our senses don't support. We cannot touch, we cannot taste, we cannot smell, we cannot hear. Then how to learn this energy? Now this is interesting. Then how to learn electrical engineering or electrical circuit analysis? How to learn network analysis, or how to learn electrical engineering in general? Okay, electrical engineering in general. Yes, how to learn this electrical engineering in general? Yes, we need to learn 2 things, sir. We learn by using 1 notations, 2 max. Simple answer, sir. If electrical engineering, then it is a sync. Simple understanding, sir. Simple understanding. in your house wires are there. Can you see current? Which direction can you tell me? No, no, sir. No, no, sir. Okay, so we cannot see. We are not taking references. So that is why in any element, if current leaves the positive terminal of voltage, in any element, if current leaves the positive terminal of voltage, then it is a source. In any element, if current leaves the positive terminal of voltage, then it is a source. Please understand, it is a source. Okay, that is the first thing. Now, similarly, in any element, if current enters the positive terminal of voltage, in any element, if current enters the positive terminal of voltage, then it is a sink. Then it is a sink. Simple understanding, sir. Simple understanding. If current leaves the positive terminal of voltage, we say it is a source. If current enters the positive terminal of any element, we say it is a sink. Source delivers power. Source delivers power, but sink absorbs power. Source delivers power, sink absorbs power. That is a notation we have to follow. Who gave this? Our great Indian authors, or foreign authors, scientists, teachers. They all gave. I don't know, sir. Alexander and Sanskrit. One of the oldest books is nickel mixed with steel will give that alloy, and once you magnetize, they stay like permanent. Now, sir, can you even see flux? Tell me how flux is going. No, sir, we cannot see. So notation is required. What is this notation? We say that flux leaves north pole externally and enters south pole externally. In any surface, if flux is leaving the surface, we have to consider it as north pole. So flux leaves north pole externally and enters south pole externally. Okay. Or Bruce gave, or scientists gave, engineers gave. How can we learn? Now, one of the greatest notation is example 3. One of the greatest notations is ampere right hand thumb rule. Ampere right hand thumb rule. Okay. Now this is one of the greatest notation. What does it say? Yes. If a straight current carrying conductor. Okay. If a straight current carrying conductor. Okay. If current is indicated by the thumb. Then the closed fingers indicate the orientation of flux. Closed fingers indicate the orientation of flux. That is great notation, sir. Without this notation, tell me, without this notation, how can you understand force between conductors, transmission lines in EC and waveguides? Notation, sir. Even Ampere don't know really that is correct, but he took like this and started. Nah. Even Ampere did not prove that is correct, but he took a notation and did. Now tell me, sir, everybody. I will ask an interesting question. Let me see how many will. I will ask an interesting question. Okay, electron is positive or negative? Electron is positive or negative? Electron is positive or negative? Tell me, everybody. Electron is negative. Who told electron hold up? You think that electron, when you see through microscope, is carrying negative charge on its head? You think electron told you that is negative? Notation. That is what I'm trying to tell you. See, so many told electron negative. But who told electron told you? Notation, sir. Electron negative, take it. Proton positive, take it. Who took it? Human beings with notations took it. Electron did not say it is negative. Some students in my college, they think that when you see through microscope, electron is carrying negative on its head. They think that electron is carrying negative on its head. Wrong, sir. Electron is negative is a notation taken by human beings. Please understand this. Electron is negative. Proton is positive. Coulomb's force of attraction. Current and close finger suffix. So notations. That is the meaning. Sir. Notations are important. Electrically can be classified into. So as an electrical engineer, any material in the world I can split in 3 ways. Any metal in the world, according to me, are my 3 fundamental passive properties. Please understand. Any metal in the world can be classified into 3 fundamental passive properties in electrical sciences. That is RLC. What is resistance representing? Resistance is a component, I know. But what is resistance representing? Resistance represents linear time invariant property of matter. So what is resistance representing? Linear time invariant property of matter. Inductor represents what? Electromagnetic property of matter. Wherever it is there, model is inductor. And capacitor represents electrostatic property of matter. Now example, listen carefully, sir. Example. Transmission lines. You see students, listen now. Transmission lines. Okay. Now, where are our transmission lines? Telephone lines. Does transmission lines have resistance or not? Yes or no? Does this transmission lines have resistance or not? Yes. Even though it is a good conductor, they have resistance. So all copper and aluminum conductors have resistance. Yes or no? Now, these transmission lines have inductance or not? Yes, electromagnetic property. Because inductor represents what, sir? Inductor represents what? Electromagnetic property of matter. So when this flux, yes, when time varying current is flowing through the wire, electromagnetic flux orients and that will link the coil and exhibits inductance or not? Yes, inductance is also there. Yes. Now, where is capacitance in transmission line like our telephone line? A charged conductor with respect to ground. See, these telephone lines, sir, they run above the ground. But this telephone line is charged. This charged conductor above the ground is like a virtual capacitor. Air is acting like an insulator. Yes or no? This charged conductor above the ground is like a virtual capacitor. Yes. So there is a capacitor also. That is why our transmission lines, which are our telephone lines, can be modeled in terms of RLC circuits or not. Because resistance represents what, sir? Resistance represents electromagnetic. Sorry, linear energy. Yes, exhibits what? Exactly half an hour break. Relax, sir. Close your eyes. Relax. Have a cup of tea or milk. And again, 7:30 we will start. 9 o'clock after completing, I will take out. Sir, see, so many are asking, sir, why DC power, why AC power only? I will tell all this, sir. Don't worry. There is a lot of time. This is introduction only. So half an hour break. 7:30 we are going to come back again. Okay, na? Don't worry. This is introduction class. Don't worry at all. Lot of things and many repetitive times I will teach you, but this is introduction. Yes, everybody come back, please. Can you see this? Can you see me, everybody? See, sir, I'm turning off video only for the reason of internet speed and sometimes my voice keeps breaking. I have had fiber net connected here at my house, but still, Geo did not come to our house, sir. This area still Geo is spending. Once Geo comes, I will take Geo. I heard that Geo speeds are ultimate. Yes, I heard that Geo speeds are ultimate. But still, everybody, please come back. I'm waiting for you. Still, some more students will log in and come back because the morning that is previously strength was very high. See, the reason I'm turning off my video is because of the internet speed. And sometimes my voice keeps breaking because of load in the internet, etc. etc. That is the reason. That's it. Okay? I want everyone to come back because I want to brief out 7 things and go with a lot of things today. Everybody, please come back. I want to discuss a lot of things today. So, everybody. Some more students, please come back. I'm waiting. Don't worry. Don't. It is my duty to give that. Don't worry at all, please. Okay. So I'm coming off now. This is a video only. Now everybody is now. So now, sir, the subject is electrical circuit analysis particularly. Okay. And it is also a network analysis for EC or basics of circuits for instrumentation. Okay. Now, how to get full marks? Now, that is what I was asking. Like, how to get full marks? I told that's 4-step mantra. I told the 4-step mantra. Just follow our notes. Be perfect in our notes. Revise many times. By heart it. Remember all the formulas. Volume 1 class work I'm going to do already. Volume 2, the material what you get. Please do the complementary problems. Like if I do inductor problem, capacitor problem there. Okay. If I give ladder network, T network, that practice is important and a lot of flexibility you get. Then step 2. Some students who still want more practice or even toppers, I request that go to IES first. Okay, IES objective, both theory and electronics and telecommunication. Why? Because together it is covering a lot of bandwidth. And then go to gate. Gate you read later because gate is more mathematical and deep. IES gives width, gate gives depth. That is my simple conclusion. IES bits gives width in the subject. Lot of idea, lot of parameters. But gate bits give a lot of depth in the subject. Okay. Then by November, October, please write exams. Every subject analog, write 20 exams. Network, write 20 exams. Digital, 20 exams. Both online and offline. We have the test series also for you. Register into test series, which is free of cost for ACE Academy. I think so. I don't know all this, sir, but yes, for ACE Academy, the test series is there. You're registered into test series, and once you complete your preparation, keep writing. Then we will give you ranking also, all India ranking also, and you have to practice and improve because time management is deadly in these exams. Very deadly. Okay, this is my 4-step mantra to get top rank. Now, I never mentioned any textbooks. Yes, but still, if anyone wants reference, these are the ultimate books, sir. Nothing else. I don't prefer anything else beyond. 1. Sadhguru wrote EMF, parabolic, step. We know register. Even I like topology, network topology, or graph theory. Okay, network. But number 1 AC waveform is sinusoid only. There is a reason which I will tell you later. Leading means current leads voltage, inductor, current lags voltage. Okay, that is how we study. All resonance, magnetics, and their transient analysis will come. Okay, transient analysis will come. Then extra topics like 2 ports, network functions. Okay, topology. Even I like topology, network topology, or graph theory. Okay, network topology, or graph theory. We call it graph theory. Like that, so many miscellaneous topics are also there. But actually, graph theory is there only for IES, not in gate. Okay, is there only for IES, not in gate. Okay, we will do such extra things. Okay, and the 3-phase is there only for electrical people. Like that, sometimes in electrical branch I need to teach this extra. Otherwise, 90% of the 90 bulk quantities are always small packets, but most importantly, long distances, and most economical. IES syllabus. So how can you neglect that? When you work in Indian Railways, you should also know that, sir. Don't always think that you will get job in communication and signal area. No, it may be even power related. Instrumentation people also, how you need to design voltmeter, ammeter, CTP at power level. So we learn this energy both at power level and signal level. Mostly electrical and power level means high voltage, high current, high power, and frequency is 50. EC and instrumentation we majority learn our applications at signal level. Signal level is low voltage, low current, low power, but high frequency. Okay, low voltage, low current, and low power, but high frequency. Yes or no? Yes. Now, sir, because of the difference in power level and signal level, now listen carefully. Because of the difference in power level and signal level, everybody. Yes, because of the difference in power level and signal level, their performance parameters are different. Okay, for power level, yes, efficiency, power factor, cost, safety, reliability are important. Like I gave an example of air conditioner. Yes, air conditioner. Yes, please understand. Power level product. Okay, there we see efficiency, power factor, etc. But when it comes to cell phone is a signal level product. Cell phone is a signal level product. Their precision, accuracy, speed, compact, portability are important. Okay, so that is the basic difference between power level versus signal level. Okay, then that is what you see. Like a 210 AC is 2 kilowatt, but a cell phone is hardly 55 watt. You see the charger rating that will tell you that. Okay, now, why electrical engineering is tough? So many say electrical science, EM stuffs are confusing, like that they say. Okay, electrical engineering stuffs are confusing, that is what they say. Okay, electrical engineering is tough. Yes, and the reason, yes, our senses fail to support. So electrical engineering is tough because our senses don't support. Okay, our senses don't support. That is a big problem there. Okay, sense of touch, sense of vision, nothing will help us. So yes, how to learn this? But still we can learn models, modeling in terms of ABCD parameters, notation include what symbol, units, direction, fraction, your screen. Okay, so suppose. That is important. So we know capacitors, electrostatic property, and where are capacitors in your house? Ceiling fan, pulse and digital circuits, computer board, filter, like that everywhere. But how to learn these after notations mathematically? That is why I told how we are learning electrical engineering means. Yes, that doubt I gave. How we are learning electrical engineering means we learn electrical engineering by using notations and maths. That is what everyone should understand. We learn electrical engineering by notations and maths. What is notation? Notation is taking symbol, polarity, direction, electricity, units, etc. But mathematically we learn. What? Sinusoid. Okay. Let's suppose if I give ideal AC, which is sinusoid. Everyone watch this. Okay, ideal AC sinusoid. Now everyone listen now. Yes. Suppose if I take this V equal to Vm sin omega t, then I equal to C d by dt of this Vm sin omega t you have to put. Then you'll get some expression, right? The derivation we'll do later. We'll get something like, okay, Im sin omega t plus 90. This I will tell you later. Okay. But what is the conclusion? When I use sinusoidal voltage across capacitor, current through it is also sinusoidal, but current leads voltage by 90 degrees in phase. Then I will do it later. Don't worry. In 5th chapter, the derivations will come. So please understand. So how we are learning the world, how we are understanding the world in electrical engineering. That is my question, sir. How we are able to understand this world in electrical engineering. Yes, we are understanding this world in electrical engineering. Please understand. Yes, we are understanding this world in electrical engineering by using notations and maths. Okay, notations means here, for example, you see. Yes, for example, you see notations. What are notations? Yes, the notations are taking symbols, taking polarity. Yes, taking symbols, taking polarity. All this comes under notation. Okay, all this comes under notation. Okay, and also maths, like Ohm's law. Ohm's law is I C by dt. And from the Ohm's law, for ideal AC we have declared and understood that capacitor is open circuit, and for ideal AC we understood that yes, for ideal AC sinusoid, current leads voltage in capacitor by 90 degrees. This all will prove, sir. Don't worry. Right now, understand mathematically. That is what I'm arguing. How we are learning everything as electrical engineers. Notations and maths. But I will ask a simple question. Now I'm asking a simple question. Does really current flows? Through capacitor? Does really current flow through capacitor? Yes or no? See how we are saying here mathematically for DC, capacitor is open circuit, and for sinusoidal AC, yes, sinusoidal voltage will use sinusoidal current, and current is leading. That is what we are doing mathematically. Nothing wrong. Can you now tell me, does really current flow through capacitor? Everybody, does really current flow through capacitor? Yes or no? Yes or no? My answer is no. That is the meaning. Really current cannot flow. Then how capacitor will work? But capacitor will work based on the principle of polarization. Capacitor physical current will not flow. Conventional current, but it is working because of the principle of polarization. Yes, it works. Due to principle of polarization. I write like this. It works due to polarization. Now listen carefully, sir. So that is how, sir, though mathematically we are understanding and learning this physical world, but is really current flowing through capacitor? No. Physically current will not flow, but how it is working polarization. What is this reason, sir? Suppose I take a parallel plate capacitor. Watch this. Suppose I take parallel plate capacitor. Okay, separated by dielectric plate B A also. Okay, now suppose I give this voltage DC voltage polarity like this. Suppose I give DC voltage polarity like this. Let us say it is a chemical battery. Now positive ions will attract all the negative here, and remaining positive will accumulate here. That is called polarization. Okay, so what happens here? Positive will attract all negative, remaining positive will be here, and negative will attract all positive, and remaining negative will be here. Remaining negative will be here. Then strong electric field is developed. The strong electric field is developed from plus to minus, and that polarizes the dipoles. Polarizes the dipoles. Polarizes the dipoles. What are dipoles? You have dipoles in physics, sir. Dipoles are molecular, molecular particles which are electrically, like they are attracted to each other but separated by distance. Dipoles are like charges where positive and negative charge are attracted but separated by distance. So these dielectric materials will have dipoles. So capacitors mainly have what, sir? Yes, capacitors mainly have dielectric material. Dielectric material. That is very, very important. Dielectric material. What are dielectric materials? Dielectrics are insulators, but they exhibit polarization. Dielectric material exhibits polarization. Polarization. Okay, but what is happening now? See, when you give this polarity, here plus in the chemical battery will attract minus and remaining plus will come here. Minus will attract plus and remaining minus will come here. That process is called polarization. And once these charges separate, now the electric flux lines will go from plus to minus. Thereby, the dipoles get polarized, and this is how the polarity of the voltage appears across the capacitor. Now, suppose you reverse the polarity. Now, see this concept, everybody. Now, suppose you reverse the polarity. Okay, suppose you reverse the polarity. Reverse the polarity. Now this is interesting. Suppose you reverse the polarity. Now see the same parallel plate capacitor. Now what I'm trying to do, I will ulta polarity. What I will do, this plus, this minus. And again all minus will attract plus and remaining minus appears here. And all plus attract minus and remaining plus will appear here. Okay. Now electric flux line go from plus to minus. Okay, electric flux line go from plus to minus. Okay, here what I did, I reverse the polarity. Thereby, what is going to happen to the dipoles? Okay, dipoles are the particles, available in dielectrics, abundant, and now this is the polarization these dipoles take, plus, minus, and that is how they accumulate the charge. So see the difference. If I use this polarity, that is how the charge gets accumulated to polarization. If I use this polarity, that is why if you use sinusoidal voltage, sinusoidal voltage, positive cycle 0 to pi, this polarity will come, and negative cycle pi to pi, this polarity will come. That is how capacitor is working because of polarization, and hence this current is called. Hence this current is not conventional current. In normal conductors like copper conductors, silver wires, etc., that current is called conventional current. Their physical charge will transfer. You understand, sir? In normal conductors, yes, current, yes, will physically or charge will physically transfer. In our house, sir, all electrical copper wires are there, their charge physically transfers, and that's why the current is called conventional. But here in capacitor, physically current and charge is not transferring; it's only polarizing. For this polarity, this plate is positive, negative, and for this polarity, this plate. So the material inside is getting polarized. The dipoles are becoming ulta, positive, negative, up, down. That's how the charges are getting accumulated, and that's why this current in capacitor is what current, sir? Remember? Is displacement current. Displacement current. Please understand, this current in capacitor is called what current? Displacement current. Everybody please understand. This current in capacitor is called as displacement current. Please understand this displacement current. Normal current in our conductors are called conventional current, where current flows straight off charge. Here, polarization takes place, and that is why the current is called what? Displacement current, and that current is a function of charge. So please understand, sir. See how we model and learn. So this is theory versus practice. Capacitor is an passive element which represents what property? Electrostatic property. Okay, electrostatic property. Okay, and how we are learning electrical science by using notations and max. Example, taking symbol for capacitor, polarity for voltage, direction for current, units, all are notations. Okay, notations. And what is the max? Ohm's law, for example. Later we'll learn Coulomb's law, so many things, but Ohm's law, for example. Ohm's law for capacitors is CD. And from Ohm's law we are learning mathematically see how simple it became. That for ideal DC, capacitor acts as open circuit. For ideal DC, it is a leading element. I will do, okay, the derivation I will do later. But that is how we learn. Then I ask the real question, does really current flow through capacitor? No. Yes, sir. Actually, physical conventional current is not flowing. Then how capacitor is working? Due to polarization. I explained that polarization, sir. When you do a specific voltage, the charges get separated, and this process is called polarization, and that is how charges get accumulated in the plates, and electric field is developed, and that field is stored in the electrostatic energy. Okay. Then if I reverse the polarity, yes, again the electric field direction reverses, and dipoles get reverse polarized, and that is how the energy stored in the electrostatic field. Half C square. So concept clear. Okay, now. So that is how, sir, everyone please understand. That is how, yes, we are learning all these things. Notations are helping. Okay, that is the basic difference, sir. See, one way engineering is all max, but science is telling something really different. So that is why I say conclusion. Yes, that is why I say conclusion that engineering is application of science. Conclusion, first conclusion that I am giving today is yes, engineering. Okay, engineering is application. Engineering is application of science. 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 So please understand. Engineering is application of science. So please understand. Read this what I'm trying to do here. Everybody read this what I'm trying to do. Okay, now sir, please understand. But that's why after observing, see, mathematically we are learning something, but yes, engineering is an application of science. So as an engineer, please learn more applications. Try to learn more applications, sir, not just notations or definition. Application. So GATE is a great application paper. Graduate aptitude test engineering is all an application paper. Okay. So now sir, with all these basics, so we learn the importance of electrical energy, why it is so special for electronics and communication people and instrumentation, precision, accuracy, portability of our parameters. Then though electrical engineering is tough generally to understand, but we are learning with notations and maths. I told examples of notations and maths. Okay, and then I give an example like capacitor symbol. So like capacitor, inductor, everything we learn like this by using notations and maths. Okay. So now I say a conclusion that engineering is a great application of science. Okay. So now let us start the serious subject, sir. Now I want everyone to concentrate here. Everyone should concentrate here because we are starting the subject now. Okay. So sir, everyone listen now. So the first thing I start in my subject is the difference between circuit versus network. Listen carefully, sir. Circuit versus network. Now everyone will get this out. Sir, why sir? For us, like we all ECE, like network analysis. But electrical say circuit. What is the difference, sir? Yes, there is a unique difference. Please understand. Now I'll give an example directly. Suppose, yes, I'm writing here. Everybody watch these examples carefully here. Like some 10 volts supply, 1 ohm, 2 ohm, 3 ohm. Okay, 1 ohm, 2 ohm, 3 ohm. Okay, and here also I'm taking a similar example but slightly modified. So this is something like 10 volt, 1 ohm, 2 ohm, 3 ohm, and this is 4 ohm, and this is 4 ohm. Okay, 1 ohm, 2 ohm, 3 ohm, and this is 4 ohm. Okay, everybody now listen now. Now, what is the difference? See, first of all, circuits and networks are interconnection of various elements tracked together. Everybody please listen. Now, this is the real start of the subject. Please come back. Some students are leaving. It will be a great disadvantage for you. Okay, now listen. Circuits and networks are interconnection of various components tracked together. First of all, understand that circuits and networks are interconnection of various components tracked together. Like you see here, a DC voltage source, 1 ohm, 2 ohm, 3 ohm, all resistors are there. Here also DC voltage source and 1 ohm, 2 ohm, 3 ohm, and 4 ohms are there. So circuits and networks are interconnection of various elements to act together. But the rule is in a circuit. Okay, but the rule is in a circuit. Okay, current is intended to flow in a circuit. Yes, current is not very important. In a circuit, current I is intended to flow through all the elements. That is important, sir. Elements. Listen carefully, sir. In a circuit, current is intended to flow through all the elements. Now, what are the requirements for a current to flow? Tell me, what are the requirements for current to flow? Now, current requires two things. Okay, first driving force voltage. Or EMF. First, it requires what? Voltage or electromotive force. And the second requirement is what? Closed path. Please understand, everybody. So, circuits and networks are interconnection of various elements tracked together. But in a circuit, the mandatory rule is current is intended to flow through all the components or elements. Please understand this, sir. Current is intended to flow through all the components or elements. But what are the requirements for current to flow? One, driving force voltage, and second, closed path. Now listen carefully, sir. Now this is a circuit because there is a driving force, yes. And all interconnected and closed now. See, current leaves positive terminal and comes back to negative. It will go here, divide, again combine and come back. Yes or no? Yes. So first of all, driving force is there and closed paths are there. So current will flow through all the elements. Hence, it is a circuit. But sir, what about this, sir? Now tell me, can current flow through these forums? No, sir, because one of the condition is failing. Though there is a driving force 10 volts, but there is an open circuit, no closed path here. So current cannot flow through 4. Hence, it is a network. So my conclusion here is yes. Here, current cannot flow through 4 ohm. Current cannot flow through 4 ohm. Hence, it is network. Please understand. Current cannot flow through 4 ohms. Hence, it is a network. Please understand. That means in a network, it is not mandated that current should flow through all the elements. Please understand this difference. In a circuit, first of all, in a circuit, current I is intended to flow through all the components. But in a network, it is not mandated that current should flow through all the elements. But now, sir, see this, sir. But this network has a circuit in it or not? Yes, networks can have circuit in it. Because circuits are building blocks of networks. Yes, networks can have circuits in it. Please understand that, sir. Circuits are building blocks of networks. See, left side is pure circuit, right side is network. Why? Because current need not flow through all the components. But in that network, there is a circuit part where current is flowing. That part where current is flowing is circuit. Simple meaning. So now first tell me, sir. Now everybody tell me. Everybody, your house right now is a circuit or network. Tell me, sir. Your house is a circuit or network. Let me see some answers. Your house is a circuit or network. Yes, I'm getting correct. Some are giving wrong answer. It is a network. Some are giving circuit. Your house is a network. Why? Because every application, every element is turned off. You tell me now, everybody. Every element is turned off. All refrigerator, okay, refrigerator on, sir. But all lights are on, all fans are on. Some rooms are off now. Yes or no? Now pump motor is not running now. Mixer grinder is not running now. So please understand that your house is a big network of connection of so many components. Some of the components are not turned on, so current is not flowing through them. Some of the components are not turned on, so current is not flowing. But that part where current is flowing is called circuit. But your total home network is network only. Please understand this difference, sir. Your house is a very big network. In that where current is flowing is circuit. Now tell me, your entire area, suppose you are living in Hyderabad, Abids area. Now the Abids area is circuit or network. It is network only, sir. Entire India is also network. Because so many areas power is cut, so many shops are closed by night. Yes or no? So many offices are closed by night. So practical big systems are always networks. But that part where current is flowing is circuit. Now that is the point I'm writing here. So everybody listen now. See, all our practical, please listen carefully, sir. All our practical big interconnected. Okay. All our practical big interconnected systems are networks. Okay. But that part where current is flowing is circuit. So, but we do circuit analysis. Okay, to those parts or to that part where current is flowing, Please read this statement, everybody. So I want everyone to read this. So left side is a circuit because closed path and current is flowing through all the components. Right side is total network. Because current cannot flow through 4. But in the right side network there is a circuit part in it. So our home is a big network. Our power system is a big network. Our communication system is a big network. But that part where current is flowing is a circuit. And current requires two important conditions. What are the two conditions for current flow? Everybody, what are the two conditions for current flow? Always important. First, there should be a driving force or voltage. Second, circuits are building blocks of networks. Okay. Now, I will give you an example. Our communication system is a big network. Okay, our communication system is a big network, but a transmitter working in it. But a transmitter working in it is a circuit at signal level. That is the best way to answer. See, our communication system is a very big network, sir. Okay, but a transmitter working in it is a small circuit at signal level. Yes or no? Now, electrical example also I would like to give. Maybe instrumentation students like it. Just orally I'm telling you. Like electrical people want to say their power system is a very big network. Yes or no? Their power system is a very big network, but a transformer working in it is a circuit at power level, like that. Their power system is a very big network, but a transformer or a motor working at circuit at power level. Okay, like that. Okay, that is the basic difference. Now, why this triple and DC difference came out? Now, why this difference came out? This is a very remarkable difference. Now, this is very important. See, this is after analysis of so many things, we can control. Now, why for electrical people, this subject is called as circuit analysis, and why for EC people it's called network theory. Now we know the difference between circuit and network now, but why this difference came in the name? You see any university, sir, even in JNT affiliated college study, or you go to IIT, NIT, for electrical power level people we call this subject as circuit analysis. And for EC people we call this as network analysis. Now why this difference came? The difference came because of applications, sir. Now listen carefully. See, EC and instrumentation students, we study at signal level now. Mostly. Most of our applications are signal level. So at signal level, communication can be done without physical connection. At signal level, communication Okay, communication can be done. Okay, without physical connection, also. Okay, example, Wi-Fi. Yes or no, Wi-Fi, Bluetooth. Yes or no, Wi-Fi, Bluetooth. Okay, so many things we learn. Wi-Fi, Bluetooth. Okay, mobile communication, satellite communication, mobile and satellite communication systems, etc. Yes or no, communication, all wireless answer. So that means ECN instrumentation students, we are able to do communication at signal level without any physical connection. So that is why I can say, yes, we learn more network concepts. That is why we learn more network concepts. Okay. Now, triple E students at power level, physical connection is mandatory, otherwise efficiency is poor. They are not transmitting signal, sir. They need to transfer energy at power level. So yes, energy at power level, okay, is possible by physical connection. Physical connection only. Okay, example, you see their machines, power systems, all wires, power systems, etc. Okay, that is why they learn more circuit concepts, closed path concepts. Now listen, sir, I'll explain it. So everyone listen, sir. See why this difference came between circuit theory and network theory for triple ECE? That is a beautiful answer. Why? Because we as ECE students and instrument students, most of our applications are signal level. Signal level we can do communication without physical connection. Network concepts come like Wi-Fi, Bluetooth, mobile communication, satellite communication, etc. But electrical people at power level, okay, they all talk with physical connection. Like machines and power systems. Now see carefully. Now, sir, everyone listen carefully now. Okay. Now see, your cell phone is there. Okay, cell phone, you are calling to your friend. Everybody listen carefully. Your cell phone is there. You are calling to your friend. Your cell phone is one circuit. Okay, your friend's cell phone is another circuit. But are they physically connected? No, na. Your cell phone is one circuit. Your friend's cell phone is another circuit. But are they physically connected? No. Okay, both are independent circuits. That is why you say, अरे तुम्हारे phone में circuit है या network है? You say na, अरे नहीं phone लो circuit ना network ना In English we say, अरे your phone has circuit or network. Please tell me this. Your phone has circuit or network. What is your answer? Yes, network concepts. Because your phone is already a circuit. But your phone has network. Because Vodafone is a network, Airtel is a network. Satellite communication is a network concept. That means your phone is one circuit. Please understand. Your phone is one circuit. Your friend's phone is another circuit, sir. But both are physically connected. No. But mobile communication. So that's why you ask your friend, "Hey, your phone has network." So this Airtel, okay, this Vodafone, this all these are network concepts, sir. In your house also so many are network concepts, and some are circuit concepts. That's why you see your fan, AC are circuit concepts. But your mobile phone, okay, your mobile phones, Bluetooth connected devices, speakers are all network concepts. Please understand this difference, sir. Because ECE and instrumentation students are very weak signal level communication without any physical connection, like Wi-Fi, Bluetooth, satellite communication, mobile communication. Both are different circuits. But together we learn network concepts in frequency domain. But electrical people at power level we need to transfer energy with physical connection. Otherwise efficiency won't come. All transmission line transformers are electrically connected, physically connected. So circuit concepts are more in machines and power systems. Because of this application difference, see that's how beautiful this subject. Because of this application difference. Yes, because of this application difference, everyone should understand. Yes, everyone should understand. Because of this application difference, electricals learn circuit theory, ECE learn network. Simple example I'm giving us, sir. Mobile phone, you will say, "Arey, in your phone network is there," but you will never say, "Arey, in your phone circuit is there." Because already it is a circuit, but you are trying to communicate without physical connection. That is where network concepts will come more. So ECE students, please understand that you learn more network concepts, but electrical people learn circuit concepts. Okay, that is a basic difference. So I'm writing the conclusion now. Yes, triple E students. Okay, first ECE students. Okay, or instrumentation students. Okay, all our practical applications are very as well. Mathematically modeled as a circuit or network. Mathematical network, I will show you the resistor energy. What circuit or network? We use fundamental network components to model them. What does it mean? Listen carefully. Example. I want to learn about a heater, sir. Now, heat is an application which converts what? Yes, electrical to heat energy. Yes or no? Heat is an application which converts electrical to heat energy. But finally, this heater, as a mathematical network, I will show you the resistor because resistor is the only element which has the ability to convert energy. So finally, heater is a resistor model in my subject. And after modeling this heater, now power absorbed by the heater is either V into I or I square R or V square by R watts. Yes or no? If it is a DC voltage, DC current, directly DC values you take. But if it is a sinusoidal AC voltage and sinusoidal current, RMS values you take. RMS root mean square. Why RMS I will tell you later. So please understand, sir. So heater is an application. Now see the link to this statement. Heater is an application which converts electrical to heat. We use it. But when you want to understand this heater, you need to mathematically model in terms of network or circuit. And that is why I am modeling heater in terms of what? Resistor. Okay, I'll give you another good example, sir. This is a very good example. Now you see ECE and instrumentation. Suppose I want to understand about BJT. What is BJT? BJT is a component or device. Tell me, BJT is a component or device. BJT is a bipolar junction transistor. And it is a semiconductor material based device. It is used as a switch, it is used as an oscillator or amplifier. But if you want to learn about a BJT, you need to build it sequence circuit or not? Yes, if you want to learn about a BJT, please understand this. Yes, if you want to learn about a BJT, you need to build its equivalent network. That is where we write its H parameter model. Now that is why BJT is represented as a current dependent current source. BJT is represented as a current dependent current source. BJT is represented as current. So this is base resistance. This is IB. This is beta IB. Okay, and this is V. Okay, I can say this is VCE. Okay, we say this is VCE because this is base, this is collector, and this is emitter. Example, you will learn this in ABC, sir. Don't worry, ABC and blocks are written. But sir, BJT is a device made out of semiconductor. Okay, BJT is a device which is made out of semiconductor. Okay, but to learn BJT, I need to build its H parameter model. This is what, sir? H parameter model. H parameter equivalent network. So now again link to this statement. All our practical applications like transistor is a component, but when these applications are mathematically modeled, we use a circuit or network model, and that is where your VIRs is coming, like a voltage source, dependent current source, resistor, etc. Now you are the best example, sir. This is the best example. Another example. Suppose I want to learn about a motor, ceiling fan. Okay, fan I want to learn. What is fan? Fan is a single phase induction motor. Fan converts electrical to mechanical. Fan converts electrical to mechanical. But fan has got what? Main winding. It has got auxiliary winding. You study this in electrical technology. It has got capacitor to start. There is a centrifugal switch. Okay, there is a centrifugal switch, and there is a short circuited rotor. What is a short circuited rotor? So yes, practical coils have resistance and inductance. There is a capacitor, switch, and short circuited rotor. But fan is an induction motor, so we give what supply? AC supply. AC sinusoidal voltage we give. Okay, then based on that AC current will flow. So that is also, though fan is an electrical application which converts electrical to mechanical. Okay, which converts electrical to mechanical. Yes or no? Fan converts electrical to mechanical. Okay, but yes, to understand about fan, I need to build its equivalent circuit. Yes or no? To understand about fan, I need to build its equivalent circuit, and that is where I present everything will VIRLC. Now see, sir, these three examples you see everybody. Heater is modeled as a resistor. Yes, heater is modeled as a resistor. Okay, then yes, BJT is a semiconductor device, but I modeled it in terms of extrametric equivalent. And then fan is a single phase induction motor which converts electrical to mechanical, which converts electrical to mechanical, but still fan equivalent circuit has resistance, inductance, capacitance, etc. Okay, now there's a meaning there. There's a meaning there. So now all our applications are our components. But when these applications are mathematically modeled as a circuit or network, we use fundamental network components to model them. That is very important. We use fundamental network components to model them. That is VIRLC. There's a meaning there. So that is what please understand, sir. Now listen, sir. I want to bring an analogy. This is very interesting analogy. Analogy. Very interesting. I want everyone to listen. Analogy. Okay, or similarity. You know the meaning, sir. Analogy means similarity. I'm writing again. Okay. Analogy means similarity. Okay. We model source family members. Okay. The main family members. Okay. Of network analysis. The main family member. You go with any family member, sir. Mother is ideal, sir. Love, zero. No ego. Okay. No ego. Nothing. She will not harm the children. Moreover, she will treat all the children equally and parallelly. So in a parallel connected system, what is same? Voltage is same. So in a parallel connected system, what is same? Voltage is same. Then I will treat current source as father. Okay, father internal resistance is infinity. Father has got tremendous aggression and arrogance, and also he is having a lot of attitude. You argue with your father, he will beat you there. Mother, you shout on her, will harm you, she will cry instead. But father, you argue and fight, he will beat you that itself. So father internal resistance is infinity. And he is a decision maker of the family. He is a decision maker of the family. So in a series connected system, current is same. So mother is like ideal voltage source, internal resistance is zero, and in a parallel connected system, voltage is same. And current source is like father. Yes, his internal resistance is infinity. Okay, and in a series connected system, current is same. Then who is register? Register is the boy child of the family. Register is the boy child of the family who always dissipates or converts energy in the form of heat. So register is a boy child of the family who dissipates or converts energy in the form of heat. But the beauty is register Ohm's law is V equal to IR. So register behavior is independent frequency. You see, yes, sir. Register behavior is independent frequency. Huh? Yes, register behavior is independent frequency. Okay, that is why if you do DC voltage, DC current, sinusoidal voltage, sinusoidal current, sawtooth voltage, sawtooth current. Okay, yes, anything is okay. So DC voltage, DC current, sinusoidal voltage, sinusoidal current, sawtooth. So register is a boy child who dissipates and converts, but boy is easy to understand because it is independent to frequency. Whatever type of input you give, the same output. So it is a homogeneous proportional component independent to frequency. That is what registers are. Okay, that is very interesting. Register. Okay, but registers are easy elements to understand. Boys are easy to understand, sir. Yes, girls know this answer. Boys are very easy to understand. But what about inductor, capacitor? Yes, inductors and capacitors are the two girl childs of the family. They are the girl childs of the family. Okay, but yes, inductor stores energy. Inductor stores energy in electromagnetic form. Yes, I should say. Yes, inductor stores energy. It stores energy. Okay, stores energy in electromagnetic form. Electromagnetic form. Yes, and a pure capacitor stores energy in electrostatic form. Stores energy in electrostatic form. Electrostatic form. Okay, now listen carefully, sir. So one way, inductor stores energy by dB. Okay, this is the Ohm's law for inductor. And what is Ohm's law for capacitor? I equal to C dB by dt. This is the Ohm's law for capacitor. Okay, V equal to LDA by is Ohm's law for inductor, and I equal to C dB by is Ohm's law for capacitor. Yes or no? That's the meaning. So in the diagram you see. That's why for DC, inductor short, capacitor open. For sinusoidal AC, inductor is lagging, capacitor is leading. And for transient, at T equal to 0, inductor is open, capacitor is short. So for different inputs, they behave differently. That's why whoever said they said that girls are very difficult to understand, sir. Okay, girls, I'm joking, don't take it personal. I treat this subject as a passion, sir. So joke, I keep joking. Okay, that doesn't matter that I'm really hurting you. Please understand. I treat like family, sir. You all just understand like this. That what are VIRLC? I told you, sir. Anything in the world, any application we model in terms of these fundamental family members. Voltage source, current source, resistor, inductor, capacitor. Voltage source is like mother, our resistance is 0, and she treats all the children equally. So in a parallel connected system, voltage is same. Current source is like father, his internal resistance is infinity. In a series connected system, current is same. Resistor is a boy child who dissipates. Boys behavior is independent to frequency. We could IR, so very easy to understand. But LNC are the most important components to develop the required energies for the transfer and conversion of energy. What inductor and capacitor will do? They store and maintain the electromagnetic energy and electrostatic energy respectively. Without electromagnetic energy, no, they depend upon frequency. Yes or no? That is why for DC they behave differently. For sinusoid they behave differently. Transient they behave differently. DC circuit, that is the DC circuit only resistor will work because inductor capacitors are not working now. That means they did not enter your life. Then AC study well, you need to give your life now, so your everything is gone. And be careful, boys. Basics. Okay, but still some people are leaving after 8:30. Sir, did they announce that it is 8:30? Did they announce it is exactly 8:30? I saw some students left, sir. See, exactly 8:30. I saw some students left. Okay, yeah. I will make it more interesting, sir. But some students left after reading my yes. Yes, after the break I started here. Okay, so capacitor, how we represent notations, and we learn mathematically, and there is a mathematical we are learning, and that is why electrical engineering becomes easy with notations and maths. And the true reason is capacitor current will never flow. Okay, it is working because of polarization. In normal wires, conductors current will flow, rate of flow of charge, but in capacitor, polarization is a phenomenon. Then I conclude saying that engineering is a great application of science. That is what we have to learn. So as engineers, master applications you learn, then you will enjoy it. Then circuit versus network difference. Circuit versus network difference. I give both are similar, but yes, network does not require all the components current to be flowing. But networks have circuits in it, so circuits are building blocks of networks. Okay, all big systems are generating networks, but that part is a circuit. Suppose in your house everything you want, sir, all lights, all fans, all ACs, geysers, everywhere current is flowing, then that entire house is circuit. Otherwise, house is network only. Okay, na? Big areas are networks. But if you can guarantee that current is flowing to every component in your house, then it is a circuit. But generally, networks are bigger and circuits are building blocks of networks. Okay, and current requires two conditions. First condition is driving force, voltage. Second condition is closed path. Okay, that's why I gave this very interesting statements and I gave a very good example also. Okay, I gave an example also. Then why the difference came? Network versus circuit. Okay, for ECE instrumentation signal level, without physical connection, we learn network concepts more. Those electrical people are for physical connection mandatory. Otherwise, we cannot transfer energy, sir. Okay, that is why power level they learn. Then that is why instrumentation ECE signal level network concepts, electrical level power, yes, circuit concepts. That is why name difference came. Now, what are network components or elements? All our applications, when we mathematically model and study, then we use these fundamental components like VI, RLC. Okay, like example, heater is a register. BJT has a dependent current source. Okay, then I say motor is an RLC circuit. Okay, like that we learn everything with these RLC components only, sir. And I told you already, resistance represents what? Linear time invariant property. Inductor electromagnetic property. Capacitor potential property. Okay, that's why you tell me in your ceiling fan, in your house everyone is having ceiling fan. Is inductance there or not? Yes, winding of the fan. Resistance there in the winding. Capacity is there. You see capacitor, the white color one. Yes, it is used for starting. Okay, then you see now analogy. So I consider our main family of numbers in network analysis is voltage source, current source, resistance, capacitor. Voltage source is mother, resistance 0, parallel system, voltage constant. Series current is constant, father, resistance is infinite. You cannot argue with father, sir. So in series connector system, current is constant. Boy child, resistor, who dissipates and converts. He's a lossy element but also converting element. But he's an easy element to understand because he depends on frequency. So boys are easy to understand. Girls behavior depend on frequency. Okay, that's why you see inductor, capacitor, different for DC, different for AC, different for transient. Okay, interesting too, sir. Don't get hurt. I'm just joking. See, I got a sister, I got a child who is a girl child. Sir, I just joke only to make this subject interesting. Okay, my daughter is there, sir. She's more naughty and more loving than my son. I'm telling you, my daughter, sir, she cry if I'm angry. She cry if I come late also. If I go late to house also, sir, she will cry. But my son is Jando. So I'm joking only. Don't take it personal. Okay. Now, yes, after understanding this family, now let us go to the next definition. Okay, let us go to the next definition. So that's why I treat this as a family. Now the next definition is yes, linear components or linear networks. Linear components. Okay, linear components or linear network. This is a very interesting definition. Linear components or linear network. Okay, let's understand what is this linear component or linear network. Now, sir, all our practical components are originally okay non-linear in nature. Okay, please understand. All our practical components are originally non-linear in nature. But any non-linear system or component, or system, okay, can be linearized. Okay, can be linearized. Please understand this. But any non-linear component or system can be linearized by small or incremental. I'm writing it here. Small or incremental changes in time. But the same system, but the same component or system, but the same component or system. Okay, or system, but the same component or system. Okay, for sudden big changes, undergoes non-linear mode of operation. Please read this. I will tell you. Understanding is important. I will give you beautiful examples. But I want everyone to read this. I'm giving you 1 minute. Component or system can be linearized by small incremental changes in time, but the same component for sudden change undergoes non-linear. Now see, it's a very, very interesting concept. Okay, now you want to listen to this. Please listen. Carefully listen. Suppose I take this function, okay, f1 versus time, and I take another function f2 versus time. Suppose the first function is like this, second function is like this. Now tell me which is linear, which is non-linear, everyone? Which is linear? Yes, first one is linear. Nah, this is linear. Why it is linear? It has got a uniform pattern. First of all, it is homogeneous. Okay, and it can be accurately mathematically modeled. Okay, mathematically modeled. Like suppose if it is a voltage function, it is a ramp function. In voltage function, I can say the function is a ramp function. Like at 0 second 0 volt, 1 second 10 volt, 2 second 20 volt, 3 second 30 volt, 4 second 40 volt, 10 second 100 volt. Like that I can predict the future. So linear systems are homogeneous systems, easy to understand, and they can be modeled accurately in maths. Their homogeneity, proportionality, this is very important. This is important. Homogeneity, proportionality. But sir, here, see suddenly suppose the voltage is increasing, suddenly decreasing, again increasing. Now tell me after this point, is it increasing or decreasing? Can you predict? Is it increasing or decreasing? No, you cannot predict. I cannot tell. This is homogeneous, predictable, but this is non-homogeneous. So this is non-linear system or non-linear response because it is non-homogeneous. It is non-homogeneous. And it is not possible to model accurately. Okay, so not possible to model in max accurately. So linear systems are homogeneous, proportional systems where you can predict its behavior, but non-linear systems are unpredictable behavior. Okay, that is the first meaning of linear and non-linear. Now, sir, now let's take a clear example. Now listen carefully, sir. This is a very important thing. Suppose there is a function f of x. Okay, I'm writing 2 times now. See, I'm writing 2 times f of x and x. Okay, now this function I'm writing 2 times. Okay, same function I'm writing 2 times. Okay, now tell me, sir, everybody, is it originally linear or non-linear? Tell me, let me see some answers. Is it originally linear or non-linear? Everybody tell me, is it originally linear or non-linear? Linear or non-linear, everybody? Non-linear, correct, sir, it is non-linear, correct. Why? Because see, initially increasing, then decreasing. But the original green curve and red curve are matching or not? Yes, I can say the actual green color curve is almost approximated mathematically, sir. But here you can say, see the difference, sir. Now see the statement. Everybody, now listen. See now, you see this graph and listen to this. What is that? All our practical systems are non-linear. The green color when I wrote, all our practical systems are non-linear. But any non-linear system can be linearized for small incremental changes in time. But the same system for sudden big changes undergoes non-linear mode of operation. That is why I say in all our engineering, components and designs, ratings or specifications. Okay, in all our engineering components, we have ratings. They are linear. Beyond that, it becomes a non-linear analysis or network linear. Okay, step 2 is what? Superposition principle, relative property. 2 minutes, we are all comfortable, have some patience. But 8:30 some students left and they don't have sir. If you don't have patience, I'm not a magician in first class, sir. Wonderful. Everything I want to teach, sir. See, that is why you see now my subject is called linear circuit analysis. Yes or no? Linear systems and analysis. Linear is a very big term, very big name. All our practical components are originally non-linear, but any non-linear component can be linearized for small linear. But now, though this green line, both I took 2 times, same function I took 2 times. Green line is non-linear. But for small incremental delta x, it is linear because it is straight line. But here, though I did draw the straight line in the second case, it is not coinciding with actual. So this is no useless approximation. Here it is approximate. Why? Because for small incremental changes, that non-linear is linear. But for big sudden changes, you cannot equate both. So you cannot model accurately. That is why I say all our engineering components have ratings or specifications within them. But if you go for 500 volts, insulation will puncture. Excess current will heat the resistor, and resistor will lose its property of linearity. Normally, our work beyond that rating, they become non-linear. So linearity is a very big requirement of circuit theory. Linearity is a very big requirement of electrical circuit and also electrical engineers. As long as it is linear, we can do analysis. If it is non-linear, we cannot do anything. So conclusion: electric circuit analysis on network theory, a component is said to be linear, provided it obeys Ohm's law. Kirchhoff's law superposition principle. Now, example for that. Yes, example. You see current. But algorithm is non-linear principle of linearity. See, what I will do is, I will do now small signal analysis. Small signal analysis. Yes, in the small range. Yes, in the small range, what I can do, I can approximate as a straight line. This is called small signal analysis. Small signal analysis of diode. So originally diode is non-linear. But I will linearize for small incremental range only. In the small incremental range, this diode is modeled as a resistor with cutting voltage as a linear component. Original diode is semiconductor non-linear, but for small incremental change in the range like 15 volts or 30 volts, I do something called small signal analysis. Why the name coming small signal analysis? Because this only small incremental change is linear. Okay, so because of this, I say diode is linear. Okay, so we will stop here, sir, with the definition of linearity. Tomorrow more interesting things are coming. Okay, so sir, ask doubts which is relevant. So tomorrow again 5 o'clock, please. Others can leave. Those who have specific doubt only please ask. General things don't ask. A lot of time is there. I will cover everything. Don't worry. One student asks why only AC became impossible. I will tell you such things. You have to wait. Okay, don't worry. But specific to the class only you ask. Okay, so.